Hello everyone, myself Arijit Nandi. Today I am going to present our paper, a survey on multimodal data stream mining for e-learners emotion recognition. This is the outline. Learning, human intelligence and emotion have entangled connection. That particular connection can be visualized in the picture. In order to learn something, we need human intelligence. And while learning, our emotional states get changed. And let's say when we are learning something, we are enjoying. At that time, our emotional state will be like we are very happy, we are enjoying. But when the particular subject or particular course is like we are not getting the subject, it is very hard to understand, then that time we will feel bored. So our emotional state will be like boredom, or we are getting annoyed. That means our emotion is negative in that cases when we are getting bored or we are not properly understanding the subject. So it affects our intelligence. Most of the time we will discontinue the particular course. And also emotions influence the attention of the learner. How? It's like when we are studying something, if our emotional state is positive in a sense that we are enjoying the learning process, that time our attention would be more, so that we are enjoying, we are not bored and bored while learning. And also it increases the learner's desire to learn, because we are enjoying. Let's say I'm learning artificial intelligence, I'm interested and I'm enjoying it. Each and every part is I'm enjoying. So what my intention would be, how can I be master, how can I do programming. A lot of things I will learn by myself. Like that's why our my desire to learn would be more. The motivations behind this work can be divided into two parts. That is intelligent tutoring system in e-learning perspective, and another is data processing perspective. In intelligent tutoring system in e-learning perspective is most of the time it happens that in e-learning the same lecture or courses end up monotonous for the students, and because of that the effort of the instructor and their instructional support become indecisive. And because of that also, there is a high chance that the student will discontinue. That means high dropout in e-learning course where the students' emotions are negative during the course. Third point, this emotion activation promotes the associative material in the long-term memory that facilitates retrieval. So during e-learning process, we need to make sure that emotions are positive, which impacts learners to become more attentive and empowering to learning. Let's say, what does this mean? That means when we are learning, as well as we are enjoying that particular topic, will go to our long-term memory. We will not forget because we liked a lot. So because of that, an enhancement in abilities of learners to discover more and score well. When you are trying to discover more, that time you will know the subject more, and this will give you a chance to like in the assessment part, you will score more, you will gather in-depth knowledge with the subject matters, and because of that you will outshine in your career. And from data processing perspective, emotion recognition in learning, it is being studied many years. Many researchers have applied various deep learning, machine learning approaches in order to study the emotional states. But the problem is that those approaches are data hungry. In order to perform complicated emotion recognition, ap- appropriate training data is required. Also, in order to get to data, we need to store that particular data. So massive data storage is required to store the history, because those machine learning or deep learning approaches will be trained, or those models will be trained based on the history data. So we need to store that particular data. But in this IoT era, the data has volume, velocity, variety. Traditional machine learning, deep learning approaches are incapable of mining those multimodal. or multi-source data in real time. Because let's say we are in a meeting, we want to know what is our emotion. Today's approach is like, let's say our facial expression will be recorded. Both of us, both of our facial expression will be recorded. Later, we will train a CNN model, convolutional neural network model, and then we will judge. Okay, this is the emotional state of Arijit throughout the meeting. This is the emotional state of your throughout the meeting. Consider one thing that we want to know right now. What is the emotional states? Can we do that? The traditional machine learning and deep learning approaches cannot do such things. This is a research challenge, is to perform the mining of multimodal learner data, or we can say the data multimodal data streams in real time, and utilize those data to design a data driven technologies that support e-learning using multimodal data stream mining. Now, emotion and its importance. Appearance in human society with individual experience and responses are called emotions. Why it is important? It's an integral part of human being that influences their behavior, decision making, ability to think, adaptability, well-being, and the way they communicate. Why this emotion is important in learning and e-learning? Because recognizing and responding appropriately to the affective condition of the students is an essential aspect, and in conventional classrooms or of human teaching is success there. Let's say in classroom, when the professor is lecturing something, that time the professor can easily understand, okay, emotional temperature of the classroom and emotional temperature of each and every student. He will try to do some fun activities in order to uh, gain their attention again, so that they will not bored. In e-learning fashion, this is quite difficult. So there is a need, like this emotional study is a must in e-learning cases. Now, in order to identify or recognize emotional states, multimodal emotion recognition approach can be visualized into two types, where we will do information fusion, and then we will try to find out the emotion. And another approach is we will use different models, machine learning or deep learning models. For each modality, we will find the emotion, and in the decision layer or decision level, we will try to go for the majority voting, and then we will try to predict, okay, this is the actual emotion. What are the emotional states that is being studied in the literature very much? So researchers are mainly concerned about the negative emotional states, that is boredom, angry, anxiety. Our intention is to make sure that throughout the learning, the emotions are positive. So this is the frequency. This is how after survey of many papers, in 40 number of papers, the emotions are boredom emotions is being studied. Then around 30, more than 35, anxiety, anger, then anxiety is around 30 papers. This is how this is the plot. These are the states that are being studied in learning literature. What are the channels that we use for in order to recognize the emotional states? For textual modality, self-reported questions, expert observations. Vocal, speech, intonation. Visual modality, head pose, how the person's head is moving, facial expression, eye gaze, keystroke dynamics, body gesture, and eye tracking, how my eye is moving. Physiological, like these are the cells, EMG, ECG, heart rate, HR, heart rate, EDA, electrodermal activity, body temperature, blood pressure level. And multimodality is like utilizing more than one modality, like let's say textual plus visual, visual plus vocal, textual plus vocal plus visual. Is also multiple physiological signal, EDA plus EEG or ECG plus EEG in such cases. These are emotional states, like which emotional states is recognized by which emotion recognition channel. So what could be the possible outcome? That is personalized learning based on emotional states. Personalized learning means the suggestions. Let's say you have studied this one a particular subject S1 with a good emotional states, like your emotions while learning S1, the subject S1 is positive. So based on your like, we can easily understand, okay, this is how the person's uh, choices, and this is how he enjoys this. Let's say I enjoy studying mathematics very much, so the suggestions would be based on like mathematics, like the mathematics related topics I enjoy very much. And understanding the need for content update. Let's say we have released a course on machine learning or deep learning, and let's say right now the like learners emotions is good enough because this is the top machine learning and deep learning. These topics are top notch, and like after 1 year or 2 years, so these more advanced topics will be discovered. So whether there is a need for this particular course after 2 year or not, we can easily understand, okay, no, our this particular module is getting more attention, or the positive, like while learning the emotions are more positive than this particular module. So we can easily understand, okay, this module needs some modifications or not, or whether it is good enough for like, okay, this is good, we don't need any upgradation also. Adaptive learning itinerary, it's like suggesting the students, okay, after this we can you can go for this topic, you can go for this topic based on their emotional states. We can like, it's a path, so that we can suggest students, okay, you should go from this topic to that topic. It's like suggesting those topics. And better understanding of students, obviously, because when we are going to study emotional states of a learner, then that time it's a bit, we can understand the students better. Okay, this is what he wants, this is how, if teach some my teaching style is, if this my teaching style is something like this, the students are more attractive, so I should grasp, or I should continue this using this strategy or this style while teaching. And when we can understand the students better, that time we can easily identify the weaker students for extra attention or not. Like some students is emotions is negative, so we need why this is negative, where the particular student is stuck. So we can easily identify the weaker students, and we can help them to succeed in their topic, and as well as succeed in their career. That will give us to decrease or lower the course dropout rate. We did a little bit of experiment. So we have, what we did, we took this deep data and we converted into stream, and then we have utilized the massive online analysis, that is MOA software, to this is a data streaming software. You can utilize this one. So we have utilized this library, and we have utilized the deep data in order to study the how emotional states are uh, calculated in stream. So that particular data set is having 32 participants, physiological recordings of 40 trials. That means 12 1280 instances with class levels, valence and aerosol. And the results are like this. We have used Naibase, Webbing tree, OZA bag ML, and as you can see that the accuracy is not that great, but it's kind of okay for the first test cases. In the aerosol measurement statistics, the accuracy for Webbing tree is 66.80%, OZA bag ML is 66.80%, OZA bag Adwin ML 66.90%. Anyone can ask a question that OZA bag Adwin ML, this particular approach is having higher accuracy, so it is the best. But for this streaming fashion, we should consider that the time foundation is there. So we can go for this 66.90% accuracy, but as well as the what is the evaluation time? The evaluation time is 36.88 second. As at the same time, Webding tree has achieved 66.80% accuracy, and the evaluation time is 7.44 second, which is less. So here, Webding for aerosol measurement statistics, Webding tree is the winner. So from this comparison, we can easily understand, okay, accuracy, much accuracy doesn't matter, but accuracy, higher level of accuracy with less evaluation time is a winner. Now these are the research challenges for the and future works, like data pre-processing point of view, data stream normalization. Most of the cases we need to normalize this data, and as data has velocity, we cannot have the prior knowledge of maximum and minimum of the data points. So there is a need for make adaptive normalization in multimodal data streaming context. Also data cleaning, outlier or anomaly detection, and missing value prediction. If there is some missing value in this, let's say we are considering some signals, if that particular missing some part of the data is missing, there will be a problem while training the machine learning or deep learning model. So beforehand, before going for the training, we can actually we need for this missing value prediction, optimal missing value prediction, so that the machine learning model can be trained properly. And multi-feature encoding, as you have already seen that while feature fusion is a technique in multimodal emotion recognition, while feature fusion, how can we combine or which modality should be combined with which modality? Because we cannot combine, we can combine with voice with facial expressions. Okay, so we should be very careful about uh, feature like multi-feature encoding, because in traditional cases we can do that, but while streaming cases, how can we be able to encode those features, multiple features, and make one feature stream? Dimensionality reduction is also necessary, and classification model point of view, how to fuse, like there is a challenge, how can we ensemble the output of each classifier in decision level fusion? One can go for majority voting, one can go for uh, weighted majority voting. How can we go, which one is good enough for for emotion recognition? We should be careful. Also algorithm selection, like according to the no freelance theorem of optimization, no single algorithm can produce the most appropriate learning model for all the problems in any domain. So there is a need to research how to select ML models, which particular model should be considered. And even many researchers are trying to find approaches to adjust parameter for hyperparameters in machine learning to set it automatically. And also unbiased evaluation, like the evaluation should be unbiased. It is good for both the cases, or it is bad, it is good for that cases with that much biasness is there. Is like when our data set is imbalanced, that time it creates some problem. So how can we resolve? And we should be very careful about all these challenges. Now in conclusion, we can say that emotion recognition in e-learning is an active research area, and with the incorporation of these IoT devices in e-learning, the amount of data has increased, and the data is having velocity, volume, and variety. And we have focused these multimodal emotion recognition approaches in e-learning scenarios that uses stream incorporating MD, multimodal data stream mining in emotion recognition of e-learners could help us understand the learner's emotion in real time. However, there are several challenges we have needed to be tackled: framework design, real-time processing and adjustment, fusion, algorithm selection, unbiased evaluation of the machine learning or deep learning approaches. And we hope that all these findings and challenges will help us, the research community, to improve the learning experience in multimodal streaming. emotion recognition scenario, and we hope that this should be beneficial to our research, those who are working on emotion recognition approaches in e-learning domain. So the references, and thank you for your attention.